sign into chat. Okay. Let's work it.
I know what I'm going to do.
Great. Oh, wait. Hold on. Switch over to the first. Okay. MATHunday is up.
Math Sunday.
Not coming with MATHunday.
Math Sunday.
So the 11th.
Yes.
We are live. Okay, great. All right, have a great show.
Thank you. All right, there we go. Here we go. All right, guys, welcome to Math Sunday, or MATHunday. So we got a little geometry problem here to get us started off, but if you have any specific questions about anything, just pop it in the chat and we can go over it. Maybe you have a quiz or a test coming up this week. Finals. About that time for finals. What do you guys prefer? Do you prefer trimesters or semesters? I've taught at schools that have, like I've taught in both situations, and I've taught in quarter systems too. But quarter systems are usually based on semesters, so I don't know. I think I prefer a trimester. Oops. All right, let me know if you guys can read that or if it's too small or whatever. If it's too high, anything like that, let me know. Just put it in the chat, let me know. When you think you have an answer, pop it in there. Let's see. We'll get into it. Those of you just joining us, if you have any questions or any concepts or anything that you want to go over, pop them in the chat. Otherwise, you know, I'll just keep putting problems up and we can just keep working on those. That's fine with me. But I'm giving a test this week to my students over some geometry, quadrilaterals, those types of things. So I figured, you know, maybe I'll try out some of these problems on you. These aren't totally the ones that are going to be on the test, but could be, you never know. Izzy over on YouTube, I thought I was a good math person, pretends I'm a bad person. Why is this so hard for me? Ooh, secret. Does chemistry include math? So it does. Chemistry includes a lot of math, but it's just kind of a lot of mathematical reasoning. So recognizing patterns and like solving equations and using formulas, that's a big part of it. So, you know, it's It is it's much more math heavy than biology for sure. But it's not, I would say it's less math than physics. I don't know. But yeah, chemistry, I really like. A lot in chemistry made a lot of things in math make more sense for me, but that's me personally. Alvarov, is it essential to learn all the properties of shapes like squares and parallelograms for the regions? There are a fair amount of geometry questions on the Regents exam, and it is a lot of the property pieces. So with the properties, so things like this question right here would be good for the Regents. But let's see. Yeah, it's so squares, parallelograms, rhombuses, it'll be a lot of stuff like, oh, they're either going to be, basically if it's a side length or if it's an angle, they're either going to be like equal to each other or add up to equal 180 if it's two angles, or they're going to be like one is half of the other. That's usually what it ends up being. Okay. Let's see. Should I skip pre-calculus? No, don't skip pre-calculus. Pre-calculus is to get you ready for calculus. There's a lot of concepts that you go over in pre-calculus, especially now that they have an AP pre-calc class. I highly recommend, especially if you're going to do AP Calc or if your goal is to do AP Calc, do pre-calc. Okay. Oh yeah, if you get into AP Chem gets into some calc stuff, but I assumed that they were asking about just regular chem. Okay, so we've got some questions in here. We've got how do I solve this? Okay. Let's see. All right. So how do we solve this? So this shape right here is called an isosceles trapezoid. Okay, so it is a trapezoid because it's a four-sided figure and we've got one pair of parallel sides. So these two sides are parallel. That's the trapezoid part. The isosceles part is the fact that these two sides are congruent. Okay, now in geometry, when we talk about, we've got like, when we have congruent sides or isosceles, right? The angles with the congruent sides, like if it's an isosceles trapezoid and these are the congruent sides, these two angles down here are also going to be congruent. It's kind of the same situation in an isosceles trapezoid. So these two angles are congruent. Okay, so the two base angles up here are congruent and the two base angles down here are congruent to each other, right? So angle B is congruent to angle C and angle A is congruent to angle D. Angle B plus angle A, because they're between those two parallel sides, these are supplementary, which means they're going to add up to 180. Okay, so I'm going to write a couple of notes down here because if you need to write a proof or something, you've got to do this. So angle B is congruent to angle C, and the measure of angle B plus the measure of angle A are going to equal 180. So if you're writing this down in a proof, this would be sort of like your plan, right? So you know you want to write down that, oh, well, angle B and angle C are congruent. And then angle B plus angle A equals 180. So now what I'm going to do is I'm going to just kind of like use these to solve it. Okay, so I know that angle B and angle C are congruent. So I know that 8x minus 16 equals 6x plus 20. Okay, so I'm going to solve this. I'm going to add 16, and then I can subtract 6x, subtract 6x. So I get 2x equals 36. So x equals 18. Okay, now that's my x value, but what I've got to do is I've got to now plug it back in up here. So 8 times 18 minus 16. Grab my calculator. Turn you on. let's see, 8 times 18 minus 16 is 128. So that means that the measure of angle B is 128 degrees. And what we just realized, or what we said before, was 128 plus whatever A is going to equal 180. So angle A is going to be 180 minus 128. So 180 minus 128 gives me 52 degrees. So all the time on this channel, I get asked to do like proofs and do more geometry and things like that. I'm always happy to do more geometry, but it does get a little bit tricky because there's so many properties that go into these things. And also going into like a proof, it's difficult to write out a proof in a way that makes sense and kind of comes over the airwaves, it comes through the screen in a good way, okay? All right, so, and this is just one of those things where, you know, you kind of have to know the properties of the trapezoids to get there, to get that through. Okay, so let's see, I'm going to go over to, let's see, let me check in. Okay, so Nave, let's see, I heard that pirate. All right, so x equals 18. Yep, okay. So, ooh, James, a harder question. With geometry still? We can stick with geometry. What are the steps to solve geometric problems in pre-calculus? So for those of you who are just joining us, mainly we focus on kind of like pre-algebra through algebra 2 on this channel. But if you have any more specific questions about like pre-calc or calculus concept, feel free to pop them in the chat because we've got a great community here and people will always be happy to jump in and help us out. Okay, so let's see what we can do. So let's do what math concepts should I focus on studying for the ACT? So with the ACT and the SAT, there's a lot of algebra 1, but there's also a lot of probability and some statistics stuff on there. It's not super heavy on geometry, but it is pretty heavy on like algebra 1 and statistics and probability. So those are the things that I would like prioritize. Maybe even like quadratics. We can get into some quadratics here if you guys want to. All right, so let's see. Let's do a quadratic. Why not? Why not? Let's see. Let me pull down this. Ooh, Ada, you're going to become a high school teacher. That's so exciting. Welcome, welcome. It's a great gig, really and truly. So for geometry, you know, that's really hard because, well, there's a lot of really good resources for geometry, but ultimately, or for studying for the content exams for your teacher certification. Oh, I'm so excited. But really, what you would want to do is go through and just do as many practice problems as you can. You know, getting your hands on an old geometry textbook, they're pretty easy to find. And you know, they're pretty cheap on Amazon, like even if you get an older geometry textbook, and you can just kind of flip through and see what you need, what are you kind of unsure about. Kind of doing all the pre-tests and stuff like that in each chapter isn't a bad idea. And then, you know, just kind of going about it that way. I would say it depends on how much time you have too. But you know, there's lots of practice exams that you can take and see where you might have some shortcomings for that. Let me see. I'm having a oh, here we go. This is what I was looking for. Okay, let's see. I mean, all right, let's do this. Somebody asked for a hard question. Let's see. So Charlie, we don't really get into integrals here because that's more into a calculus level. Evan, struggling with finding the missing angles in in parallelograms. Oh, okay. I've got all that pulled right up. Okay. So with a parallelogram, okay, I have a feeling it's going to be all geometry tonight, which that is fine by me. Okay. So a parallelogram, I assume you're just talking about just like a basic parallelogram, not a rectangle, not a rhombus, not a square, but a parallelogram here. So a parallelogram, by definition, we've got two pairs of parallel sides, and that's it. Okay. So with the diagonal, so a couple of things here. So we've got these two sets of parallel lines. So I'm going to call this A, B, C, D, and E in the middle. Okay. So E in the middle is the midpoint of A and C, and it's the midpoint of B and D. The diagonals do not equal each other. I mean, this one just looks a lot longer than this one, right? So the point E right here, it is a bisector for BD and for AC. Okay, so that's kind of what you need to know about the side lengths. So the diagonals, they don't equal each other, but they do bisect each other. And then these two sides are parallel and congruent, and these two sides are parallel and congruent. So with that being said, now we want to talk about the angles. Okay, so angle A is congruent to angle C. Okay, so angle A is congruent with angle C. Angle B is congruent with angle D. So opposite angles are congruent. Okay. So opposite angles, so across, right? They're not, so you can have consecutive angles like A and D, D and C, C and B, B and A, right? These are consecutive angles. They're right next to each other, okay? They are supplementary, okay? So angle B plus angle A equals 180. Angle D plus angle C equals 180, okay? Now, using like the properties of like using the transitive property and things like that, then that means that like if D plus C is 180 and A equals C, then D plus A also equals 180, right? So that if you're thinking about, oops, sorry, there was something going on my street. I don't know what was happening. Okay. All right. So we've got all of this going on here. So with the angles, right? These angles, again, these are going to be, this is congruent to this one, right? And then this is congruent to this one. So when you break this down into this, we've got two congruent triangles that are going on here, right? We can be breaking it down into two congruent triangles. So if you keep that in mind with finding the angles in within the triangle and things like that, right? It can get pretty simple to find the angle. But one thing to remember is that it's also going to be reflecting like transversals, right? Parallel lines and transversals. So for example, this angle here, okay, BAC here, is the same as DCE here. Okay, so this angle here and this angle here are also congruent, okay, because they're alternate interior angles. So angle BAE is congruent to angle DCE. So same thing with this one and this one, this one and this one, this one and this one. So those are all going to be congruent as well. Okay, but like if you're looking at these two on the same side, let's see, I'll use pink, I guess. Like this angle, oh, that looks just like red. Well, sorry about that. I'm gonna do green. So that angle and that angle would add up to 180 because they're consecutive interior angles. So if you keep that in mind with those types of things, I think you're gonna be pretty set, okay? All right, so let's see. So unknown echo. I'm in middle school and I still don't get scientific notation. Could you please explain it to me? Oh yes, for sure. Okay. So scientific notation is something that we use for really, really big or really, really small numbers. So instead of doing something like 45,000 million, billion, trillion, okay? If I want to do this, okay, and I want to do this times 9. Okay. Actually, that's kind of a bad example, but let's start with just what the number is, okay? Instead of writing out this whole thing, okay, what I'm going to do is I am going to simplify this down. I'm just going to make it as 4.5. Okay, if I stick my decimal there, okay, it starts here and I move it there. So 4.5, but it's not the same thing as 4.5, right? But it is the same thing as 4.5 times 10 to the something power. And that something power is how many spots we would need to move the decimal over to equal the actual number. So that's going to be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So 10 to the 13th. Okay, so look at how much easier it is to write that, right? Okay, so 45 trillion, we've got 4.5 times 10 to the 13th. So again, this is just telling me that it's 4.5, but every time you multiply a number by 10, you're just moving the decimal over to the right. Same thing as if you were dividing by 10, you're just moving the decimal over to the left. So we can use this for really, really small numbers too. Okay, so here again, if I put this here, okay, 9.6, so I can bring this down, I can say, okay, it's 9.6 times 10, but remember I said it was like dividing by 10, so to divide by 10, we actually make our exponent a negative number, okay? But it's still the number of spots that you need to move the decimal, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So it's times 10 to the negative 10th. Okay. So 4.5 times 10 to the 13th is this big number. And then 9.6 times 10 to the negative 10th is this little tiny number. Okay. Ugh, sig figs. Blech, I hate sig figs. So sig figs are significant figures. When you're doing calculations for accuracy and precision, you can't, you can only be as accurate or as precise. Ooh, I get those two mixed up. You can only be as precise as your least precise measurement. Yeah, so you can use sig figs and you can like kind of, you would have to use sig figs for like scientific notation and a lot of these things, but bleh, I hate them. Ugh. Okay, All right, so when we are like, let's say if we were multiplying these together or something like that, okay? So if we have these, and I'm gonna say I've got 3.2 times 10 to the 6th times, I don't need the dot there, I just use parentheses. So multiplied by 4.6 times 10 to the 8th. Okay. So with these parentheses here, I'm actually multiplying everything together. So I'm going to give you guys a minute to go through and work this problem out and see what you get for your answer. Okay, so let's simplify this down. Ooh, so here's what I would do. So while you guys are kind of working through this, so here's what I would do for SAT. You never learned basic statistics. I mean, have you learned like mean, median, mode, and range? That's usually in like middle school that you typically learn that. So mean, median, mode, and range, reading a box and whisker plot, reading a dot plot, maybe a stem and leaf plot. Sometimes they put those on there. But really for calculations, yeah, they're elementary and middle school. You usually revisit them every 3 or 4 years, typically. Yeah, mean, median, mode, range. There's usually not much that's more advanced than that. Every once in a while, there's a standard deviation question. Lately, the SAT has been having more and more statistics problems on there. But I would go, like, if you go online and just look up, like, practice SAT sections for statistics, there's so many practice problems on there, and that'll give you a good idea of what you need to work on and what you need to focus on. Okay. Ooh, okay. So we've got 14.72 times 10 to the 14th. Okay. All right. So if I'm multiplying these together, since with these parentheses, okay, with these parentheses, that means multiplied. So what this really is this is 3.2 times 10 to the 6th times 4.6. I'm going to change this to a dot, times 10 to the 8th. Okay, so if I'm multiplying all of these things together, oh yeah, so it doesn't matter. That's fine that you didn't do elementary in Texas. But I assume that you probably learned some statistics in middle school. If not, that's okay. Like that gap is not a super wide gap for you. You can still, like I said, mean, median, mode, range, box and whisker plots, maybe histograms might be on there, but there's not usually a tremendous amount of statistics, like heavy lifting types of questions. They're usually pretty basic statistics concepts, so like those ones that I just listed. Okay, so I'm multiplying all these together, so I can change my order. It doesn't matter. I'm going to change this order. So now I'm going to look at 3.2 times 4.6 times 10 to the 6th times 10 to the 8th. Okay, now 10 to the 6th times 10 to the 8th, I add those exponents together, and it's 10 to the 14th. 3.2 times 4.6 gives me 14.72. So I've got 14.72 times 10 to the 14th. Okay. Now, here's the thing. The problem with this answer, which I agree, like this is what you get if you multiply these together. The issue with this is that this first term here has to be between 1 and 10. It has to be less than 10, greater than 1. So this needs to become 1.472, which means I'm going to need to change this, right? Now, personally, I always have a really hard time remembering, okay, if I move my decimal to the left, I've got to add one or subtract this one or move it to the right and add. So here's what I do, okay? What I do is I think, okay, 14.72 times 10 to the 14th. That would mean if I think about what the actual number would be, I would move the decimal over 14 times. So after the 7 and the 2, I would have 12 zeros. Okay, so I know that it's got to be 14, 7, 2, and 12 zeros. So now I think about applying that here and I would have, okay, so 14, 7, 2, and then 12 zeros. So if I need to add 12 zeros here, okay, I'm going to have to add, this is going to need to be times 10 to the 15th. Since I moved my decimal over to the left one spot, okay, I moved it over to the left one spot, I'm going to increase my exponent. But again, I have personally, really, truly, I have a really hard time remembering, move it to the left, increase the exponent, move it to the right, decrease the exponent. I always get those confused and mixed up. But since I understand what it is, I can figure it out. Okay, because I know that this should be 1472 and 12 zeros. So this needs to be 1472 and 12 zeros. So since there's 3 after the decimal before I add my 12 zeros, that's going to be to the 15th power. Okay, yeah, so smaller number, bigger exponent, bigger number, smaller exponent. Totally, I get that it is a simple kind of rule. I just forget it all the time. And I think that's true for a lot of students too. So I'm, just making sure that it's okay for you to forget a rule. As long as you understand the underlying concept, you can figure it out even if you forget the rule. Okay. All right. So Jen, you were asking before if you have a, for ACT and SAT, you can still bring in your own calculator. But they do get Desmos because, SAT is all digital and they get Desmos. ACT, if you take it digitally, you get Desmos. But if you take it on paper, you have to bring your own calculator. And I highly recommend the NumWorks calculator. You guys know I'm a big fan of the NumWorks calculator. But highly recommend that. Okay. Oh. You've learned Desmos this year. Yeah, it's, I'm not a big fan of Desmos. I think it's probably that I just haven't played around with it that much, I guess. Yeah, I don't know. I need to get into it. I have been doing it a little bit more this year. But I don't know. I'm having a hard time giving up an actual calculator. Gustavo, so linear versus angular velocity. You mean absolute deviation. Oh, that's pretty nice. So linear versus angular velocity. I'm not entirely sure. Are you talking about like with physics and motion and things like that? We don't really get into that much. But if you're talking about like linear versus angular velocity, like as far as breaking it down into like horizontal and vertical, that's really just pretty sure that's just based off of like Pythagorean theorem. But anyway, short answer, no. Long answer is, give me a little bit more and we might be able to figure it out. Okay, Monica, simplifying radicals. Yes, let's get into simplifying radicals. Okay, so simplifying radicals. So a radical is square root typically. Okay, so square root typically. Monica, if you have a specific simplifying radicals question, because it actually, once you start, it goes really, really deep into things. But simplifying radicals, so we'll start pretty basic and straightforward, but let me know if you need to go further or when the level is good, okay? So radical means you're taking the square root, right? So that's what the radical symbol means. If there's no number here, that means that it's implied that it's just the square root, right? But you can have the cube root, you can have the 5th root, you can have the 7th root, whatever it is. Okay, but let's just start with square root. Okay. So the square root of anything squared is itself. Meaning like the square root of 9 is the same thing as the square root of 3 squared, which is 3. Okay. We all get that, right? We've all got what that radical symbol means. And I always like to start this off with my students because I know it feels really simple and really straightforward. Like, yeah, we know square root of 9 is 3, right? But the reason I use this is because it shows when it's simple and when it's something that you know the answer to. We practice while it's simple so we're ready when it gets more complicated. Okay, so for example, if we had something like the square root of 27. Okay, so the square root of 27, I can't take the square root of 27. But you know what I do know is I do know that that 27 is 9 times 3. And 9 is a perfect square. I can take the square root of 9. So this comes out and it becomes 3 times the square root, but that 3 can't come out. So it stays behind. So this 3 was from the 9. This 3 is that 3. So those are the same 3 there. Okay. We have square root of 48. Okay. What would the square root of 48 be? 30, 60, 90. Yeah, bacon, I'll do 30, 60, 90 triangles. So for the trig identities, that's a little bit more into like pre-calc a bit. We can do a little bit of trig. I don't know about the trig identities though, unless you have a specific question. Okay, so square root of 48. So square root of 48, if we think about these, right? Well, think about the perfect squares, right? And what are these divisible, right, by, right? So I've got 4 times 12, right? But then if I think about 12, I think, oh, well, 12 is actually 4 times 3 also. So what this is actually going to be is the square root of 16 times 3, okay? So 16 can come out and it becomes 4, but then that 3 is left behind. So it's 4 root 3. Okay. Yeah, so Spencer, trig identities is normal high school math. Yes, it's typically more into like the pre-calc, the pre-calc level, and so we tend to stick with like pre-algebra through algebra 2. So trig identities is getting a little bit up into pre-calc, but yeah. Let's see. So Mac, did you finish your study guide and the stuff that I posted on the slides? Okay, so you finished that stuff. So remember on, was that Thursday or Friday that I was talking about? Well, if you have any specific questions, like put them in there. Like if there's anything that you want more specifically, like I can put some more questions in there, but go through and read through with your properties, right? Knowing all those properties of the quadrilaterals and things like that. And yeah, making sure you can identify those types of things. Okay, I'm double checking over on YouTube. Looks like we're good. Okay. Dalton, what do you mean what's the formula for a sphere? Okay, so I think I can't remember who asked for simplifying radicals, but if you need to go into more like with the variables and things like that, let me know. Okay, so special right triangles is up next. Okay. Oh, Dalton, I mean, the formula for volume of a sphere, like, it's just a formula. I mean, I just Googled it. It's 4/3 pi r cubed. That's the formula for the volume of a sphere. So, you know, knowing when to use the formulas and things like that, that's a bigger question, right? But yeah, the formula for the volume is the 4/3 and all of that. Tristan the Rat Man. All right. Long division just of numbers or getting into polynomials? I mean, we can do both. I love dividing polynomials. Okay. But here, special right triangles. So when you learn about right triangles, right, you know that the side lengths are going to fit in with the Pythagorean theorem, right? You've got your two legs and you've got your hypotenuse. Okay. So if I know two of these, I can figure out that third one, right? So squared, squared, squared plus squared equals squared. Okay. Preston, do you mean substitution for like solving a system by substitution or just substitution in algebra for solving an equation? Okay, so if I gave you 3 side lengths, right, you could tell if it were, all right, Preston, well, I'll put that on the list. Substitution, we'll get into that in a minute. Okay, so if I give you 3 side lengths, right, you're gonna be able to tell if it's a right triangle or not because they're gonna fit in with the Pythagorean theorem, right? So if it's a right triangle, the 3 sides of the triangle will fit into the Pythagorean theorem. If the 3 sides fit into the Pythagorean theorem, it's a right triangle. So that's the converse of the Pythagorean theorem, okay? So with this gets into, so when you get into trigonometry is where you're working with the angles and the side lengths of any triangle, really, but usually you start with just right triangles. So with a right triangle, not only are the 3 sides in a specific sort of ratio, right, a relationship with each other, but you also have these specific angle measurements, okay? So if you know an angle and 2 legs, or you know 2 angles and 1 leg or something like that, you can figure out exactly what the triangle is because it's all related, right? So these two, this opening here, this angle here in this corner determines this leg's length, okay? The opposite angle determines the length of the other side. If I open it up more, it's gonna be a longer leg, right? If I close it up more, it's gonna be a shorter leg, right? It's pretty logical with that, right? That this is, if you think about that like as a pivot point, right? So with the right triangles, we have things that are called special right triangles, okay? And the special right triangles are called, they're 30, 60, 90 triangles and 45, 45, 90 triangles. So when you see these, this is a really good thing to brush up on the SAT and ACT, but I will tell you that the SAT formula sheet does have special right triangles on there, okay? But so the special right triangles, the way that it works out is you've got the right angle here, and then, so I'm gonna do that one, and I'm gonna do this one. That looks about right. Okay. They're not perfect, but they're pretty good. Okay. So here we've got, this is a 30, 60, 90. And this is a 45, 45, 90. So we're going to start with this one here first, okay? So these angles are both 45 degrees. I said this earlier, but I'll say it again. I'll say it all the time. If these angles are congruent, these two sides are congruent. It's an isosceles triangle, okay? So the way that this is going to look is we're going to do, I know a lot of teachers like to use X for these side lengths, but I don't like using X because it's usually like a solve for X thing. Anyway, but I'm gonna say this side length is A, and this side length is A. Okay. So these two side lengths across from the 45 degree angles are gonna be equal. And then this third side, this hypotenuse, is going to be the same thing as A, whatever that is, root 2. Okay. So if these are both 5, so it would be 5, 5, 5 root 2. Okay. If these are 6, 6, 6, 6 root 2. 10, 10, 10 root 2. Okay. 30, 60, 90, if this is the 30 down here, and this is the 60, okay? 30, 60, 90s are a little bit, they're not tricky, they're just weird, okay? We'll get into if the hypotenuse is a whole number, yep. Okay, so across from the 30 degree angle, this one is A, that's the value, okay? The hypotenuse is always 2 times that value. And then across from the 60 degree angle is A root 3. So if this is 8, right? Hypotenuse is 16, and this would be 8 times root 3. Okay. Aisha, what do you mean? What if it's the other way around? Do you mean like if it's 30 and 60? It doesn't matter how the triangle is turned around. It's across from the 30 degree is always going to be like the A value. Okay. Now remember, these are all related to each other. Okay. So let's do a couple of problems. Let me pull up some practice problems that we can do. Okay. Excuse me. All right, so let me put this up here. I know it's kind of hard to see these, but what if across from the 60 is a whole number? Okay, we're gonna get to those, I promise, okay? All right, so let's do, okay, so let's start with just this one. Go ahead and switch this around, okay? So I'm going to say that this is a 45 degree angle. This is X, this is Y, and this is 4. Okay. So since this is a 45 degree angle, we know that this one is also a 45 degree angle. How do we know that? Because it should all add up to 90 degrees. So 45, 45, 90. Now I know that X is going to equal Y because across from the 45s, they're always going to equal each other. Okay. But I know that my hypotenuse is A root 2. So that means that 4 equals A root 2. And I've got to figure out what A is because those are my X and Y values. So I'm going to divide by root 2 on both sides. Okay, so I've got 4 over root 2 equals A. Now, there is not a real mathematical reason for you to not leave it like this. However, still, most mathematicians and teachers and textbooks and the SAT and standardized tests are going to say that this answer right here is wrong because you've got a radical in the denominator. So what I need to do is I need to multiply by root 2 over root 2. This is called rationalizing the denominator. So I'm going to multiply by, I can multiply anything by 1. So root 2 over root 2 is 1. That gives me 4 root 2 over root 2 times root 2 is 2. So 4 over 2, that becomes 2 over 1. So my A value is actually 2 root 2. So that means that x equals 2 root 2 and y equals 2 root 2. Okay, so no matter what, you just plug it into like whatever it's supposed to be equal to, right? And that's it. Just solve for A. Okay. All right, so let's do one where the across from the 60 is a whole number. Let's see. Well, let's do this one. This one looks kind of ugly. Let's do it. All right. Okay. So here we're going to solve for x and y. Yeah, so Landon, I think is, I can't tell what your name, but yeah, the 60 is, this is a 60-degree angle down here. So this is a 30, 60, 90. So just like we said up here, right? So I'm just going to kind of move this down so you can see it, right? So across from the 30-degree angle would be our A value, right? And everything else is relative to that side. So if this is 60 degrees, this one up here is 30. Okay. So that means that A equals x, because it's across from the 30 degrees. Let's see, A root 3 is y. And then 2a is 8 root 5. So the only one that we can actually solve right off the bat is right here. The 2a equals 8 root 5. And the reason I can solve that is because all the others have 2 variables in them. Okay. So I need to figure out what my a value is. So I've got 2a equals 8 root 5. I'm going to do what I always do with solving an equation, right? I'm going to just get that variable by itself. So I'm going to divide by 2, divide by 2. So now I know that a equals 4 root 5. Okay, because 8 root 5 divided by 2, I just do that 8 and the 2. That becomes a 4, that becomes a 1, so 4 root 5. So x is 4 root 5. Okay. Now, a root 3 equals y. So that means that y equals a root 3, which means that it's 4 root 5, because that's what a is, times root 3. If I'm multiplying radicals together, what I can do is I can put them both under the same radical symbol. But I can simplify if I need to, but in this case I don't need to, because it's 4 root 15. 5 times 3 is 15. I can't simplify that at all. So y is 4 root 15. Right? So not the most pleasant of answers, but it is what it is, right? And so we just go through and we're just going to figure out what these are. We just need to remember those a root 3, 2a, and then just solve it with those radicals. Just solve it like a regular equation, okay? Yeah, they're not hard, but they are complicated, right? So remember, complicated and complex doesn't always mean hard or difficult, right? Just like simple doesn't always mean easy, okay? So it's all kind of the same thing, right? It can be a little bit challenging. Oh, Bacon, how do you remember all of these? So the way that well, here's what you can do. I mean, if you need to, so the 45, 45, I think the 45, 45, 90 is kind of the easiest because they're the same, right? And then you've got a root 2. If you forget, what you can also do is just say, okay, well, what if these are both 5? What do I get for my hypotenuse? And then you would solve Pythagorean theorem and you would end up getting, oh, if these are 5, then I'm going to have square root of 50, which is 5 root 2. So then you're going to remember that it's a root 2. Over here, I will remember it as, because all the angle measures are different, that means all the sides are different. And so a, 2a, a root 3. But again, if you just, if you're not sure, well, again, the formula sheet does give you, the angles in the triangle have to add up to 180. So this square in the corner is 90. Yeah, these are 30, 60, 90, and all of that. Root 1, root 3, root 4 for 30, 60, 90. Yeah, you could do that. Root 1, root 3, root 4. Yep. Okay. But I think it's Landon. But the 30 and the 60, those just need to add up to 90 because this one is 90 degrees. But in just any triangle, it has to add up to 180. You can just use, you can use use the trig ratios for that previous problem. For here, I mean, yeah, you can, but usually special right triangles you learn right before you learn trig, and so then you might, you won't have that to understand or to apply yet. So typically you're learning these special right triangles before you learn trig. So Lucas, you just set up with what these are equal to. But again, this is all based on Pythagorean theorem ultimately, right? So you can figure it out with the Pythagorean theorem. Okay, so I've got, solving a system of equations by substitution, and then we'll be about out of time. This evening flew by.
Yeah, I think the football games are very good.
Oh, okay. Maybe everybody's watching football. Not wanting to do math? What? All right. So if we are solving systems of equations by substitution, okay? So a system of equations is when you have more than one equation that's true at the same time. Okay, so 3x minus 2y equals 6, and x equals negative 8 minus y. Okay. So I'll give you guys a second to work through this. I'm going to work this one out using substitution. Okay, let me get that further down. But that second one is negative 8 minus y. Yeah, user, that's a good setup. Yep. So keep going down that path. So for solving with substitution, what you want to do, there's a lot of different ways to go about these, right? You can do substitution, elimination, or even graphing. Okay, if you were to graph both of these, there would be an intersection point where they would both be true at the same time. They're called simultaneous equations. So here, I've already got one of these solved for this variable. So what I can do is if 3x minus 2y equals 6 and x equals negative 8 minus y, I can take this and I can substitute it into there, because at the solution point, these x's are the same value. So I can rewrite this as 3 times negative 8 minus y, instead of writing x, minus 2y equals 6. And now I'm just solving this like a regular equation. So negative 24 minus 3y minus 2y equals 6. So I'm going to add 24 to both sides, and I'm going to combine those y's there. So I get, move this up a bit. So I get negative 5y equals 30. So y equals negative 6. Okay. And then I can pick either one of these to go, I can pick either one of these to go solve for the x value. I'm going to pick this one because it's a lot simpler. So x equals negative 8 minus y. I'm going to pull that down. And I'm going to plug in my negative 6. Ah! Meant to write 8, but I said 6. Okay. Negative 8 minus negative 6. So negative 8 minus negative 6 is the same thing as negative 8 plus 6. That gives me a negative 2. So my solution for this, my point where they intersect, is when x is negative 2 and y is negative 6. That is going to solve, that solves both of these equations. Okay. So negative 2 and negative 6. So 3 times negative 2 is negative 6. Minus 2 times negative 6, which would be plus 12. So negative 6 plus 12 is 6. Check. Negative 2 equals negative 8 minus negative 6. Negative 8 plus 6 is negative 2. Negative 2, check. Okay, so we figured that one out. All right. Have a wonderful week. If you guys have any questions that come up, you can always send me a message. Check out all my YouTube videos because we've got a lot of different lessons and little things on there. So yeah, if you need any one-on-one tutoring or anything like that, you can click the link and do the stuff. But have a great week. Yeah, bye. Oh, bye, Emily. Bye.